Okay, chapter 14, the demand for resources. Okay, and resource pricing is very important for various reasons. One, it determines money income for the household. Why? Because households provide resources to firms, and so whatever firms pay for those resources flows as income back to the household. So the biggest resource we provide to firms is our labor. And so we sell our labor to firms, and then what firms pay for our labor goes back to us as income. Firms' goal is to maximize profit, and so to maximize the profit, they produce the profit maximizing output with the least costly combination of resources. So resource prices play a big role in determining how much land, labor, capital, and entrepreneurability a firm will purchase in order to be able to produce their outputs. Resource prices will also determine how the resources are allocated. Firms that demand more of a certain resource and are willing to pay more for that resource will then acquire that resource. Also, policy issues. Should the government subsidize farmers? Does it increase or decrease profits to subsidize farmers? How much of the budget would the subsidy be? And a lot of that would depend on the resource price. Also, are executives paid too much for their labor? Should we encourage labor unions or dismiss labor unions? What about minimum wage, etc.? Okay, to look at how much of a resource a firm demands, we're going to make a few assumptions first. We're going to assume that we're in a perfectly competitive market. Again, this simplifies things to get the main points across, and that both in product markets and resource markets, the firm is a price taker. So in the product market, they can supply as much or as little of their output they want at a certain market price. And in a resource market, they are also a price taker. They have to acquire resources at their market price. Their demand for a resource does not change the price of the resource. And the demand for resources is derived demand, meaning the firm demands a resource because it has decided to supply an output that requires that resource. So if I'm a baker and my customers want cakes, then my demand for sugar and butter, for example, is derived demand because I have decided to supply cakes. And how much they demand depends on, one, the marginal product of the resource, and that is the change in total output that results from employing an additional unit of that resource. And then also the price of the product that it produces. Okay, so what is the price of the output that the resource helps produce? All right. Okay, so when we include the price of the output that the firm is selling, then we can look at marginal revenue product, and that is, what is the change in total revenue that occurs when we change the amount of resources that we employ? That's marginal revenue product. And we will look at marginal resource cost. What is the change in total cost when we employ an additional unit of a resource? For simplicity's sake, we will assume that our resource is just labor. So the firm wants to know how many units of labor should they hire in order to maximize profit. And this is where marginal revenue product and marginal revenue costs are key, because they will hire labor up until the point where the marginal revenue product the last unit of labor brings in is equal to the marginal resource cost of the last unit of labor. So if the second unit of labor brings in, let's say, $15 in revenue, and their wage is $10, okay, then the marginal revenue product is 15. The marginal resource cost, it's the change in total cost from employing that unit of labor, is 10. So yes, we will hire the second worker because the total revenue they bring in is more than their cost, okay, of their wage. And so let's say the third unit of labor brings in $10 of total revenue and their wage is also $10. So the firm will hire the third unit of labor, but if the fourth unit brings in $8 in revenue and their cost is $10, then the firm will not hire the fourth unit because the marginal cost of that unit of labor is higher than the total, the marginal revenue that unit brings in. A marginal revenue product, we will use this to draw out the firm's demand for labor, and the marginal revenue cost is the wage. Okay, so you can say wage equals marginal revenue cost. Okay, so this is the firm's demand for labor. Okay. And so we have resource wage on the vertical axis and quantity of labor demanded on the horizontal axis. Okay, so for a purely competitive firm, notice that the product price stays the same because remember, they are a price taker. Okay, so the first unit of labor produces 7 units of output, so the marginal product is 7. The marginal revenue product would be marginal product times the product price, and we get 14. Okay, so going from 0 to 1, notice the points are going to be in between because it's marginal. We're looking at the marginal revenue, and so between 0 and 1, okay, we have marginal revenue product of 14. Okay. Going from 1 to 2, okay, this 2 units of labor produce 13 units of output, but the difference, okay, the marginal product is 6, so the second unit of labor produced or added an additional 6 units to total product. Their marginal revenue product, is 12. So going from 1 to 2, okay, the marginal revenue product is 12. All right. 3 units of labor produce a total product of 18. The difference between 2 and 3 units of labor, okay, is that the third unit of labor adds 5 units of output. Okay, times by the product price, we have marginal revenue product of 10. So going from 2 to 3, marginal revenue product is 10, and then so on, and we connect the dots, and here we get our demand curve for labor, a firm's demand curve for labor in a purely competitive market. Okay, here, this is for all the other market structures, because they're imperfect competition. So this would be like monopolistic competition. It could be oligopoly, even a monopolist. Okay, why? Because these firms are price makers. And so price does not stay constant throughout production. So if a firm decides they want to produce more output, they face a downward sloping demand curve. So under pure competition, remember the demand curve is horizontal. So whether they produce Q1 or Q2, price stays the same. They are price takers. But in all the other market structures, they are price makers and they face a downward sloping demand curve. So they know that in order to produce more units, they have to sell the additional units for a lower price. And also, the marginal product of additional units also it falls. So we have two forces here that are decreasing with additional output: the marginal product with the additional units of labor and the product price. And so the marginal revenue product curve, if we were to map it out the way we did last graph, you know, units of resource and their marginal revenue product, okay, is over here. It's this blue line, okay. And so we can see it's not a straight line. A straight line under pure competition, okay, shows a constant change between quantities of resource demanded. Here, okay, marginal revenue product is declining at an inconsistent rate. Okay. So the determinants of resource demand are the factors that shift the resource demand curve. So a change in the price of the resource wouldn't shift the resource demand curve. It would only cause a movement along the demand curve, but a change in the product demand or would shift the resource demand curve, because if we decide if there's an increase in the demand for cakes, then the demand for resources such as sugar and butter would increase as well. So then the resource demand curve would shift to the right. And if there's a decrease for the demand for cakes, then the resource demand curve would shift to the left. Okay, and then also any type of changes in productivity. Productivity, again, is how much output is produced by a unit of input. So anything that increases the productivity of a resource will increase the demand for the resource, and anything that decreases the productivity will reduce the demand for that resource. Okay, a lot of times we demand a resource and use it with another resource. So for example, if a farmer acquires more land, then that usually increases the productivity of the labor he has, and that would shift resource demand for labor to the right. Any type of technological advance, usually technological improvements will increase productivity, therefore resource demand shifts to the right. It helps workers be more productive with their hours of labor supplied. And also quality of the variable resource. So if workers receive training, better education, then their productivity will increase, and that would shift resource demand to the right as well. Okay, change in the price of substitute resources also would shift the demand curve for resources. So we have the substitution effect and the output effect, and they generally go against each other, and so we need to look at the net effect to determine which way resource demand shifts. Okay, so for example, let's say there's new technology that comes along that replaces what human labor does. Okay, and if that technology drops low enough in price, then what ends up happening is the resource demand for that technology shifts to the right, and then labor demand shifts to the left. Okay, because firms are now using machines in place of human labor. There is also an output effect. So if the price of the capital good were to decrease, then production costs will go down. Firms would increase total output. And so the demand for all resources, which includes labor, will increase. Okay. So substitution effect with a drop in the price of capital would shift labor demand to the left. An output effect with the price of capital dropping would shift labor demand to the right. And what is the net effect, which way labor demand ends up going ultimately, okay, depends on which effect is stronger. If substitution effect is stronger, then labor demand will shift to the left. And if output effect is stronger, then labor demand would shift to the right. All right. Now, if capital and labor are complementary resources, meaning they are used together. So let's say there's a new piece of, like a new computer that is technologically superior, but it requires a unit of labor to operate the computer. All right, so let's say the price of the computer drops. There is no substitution effect because the computer doesn't replace labor to begin with. Even, the price of computer dropping, it still needs a unit of labor to operate it. However, there is an output effect. If the price of the computer drops, then production costs go down, output increases, and demand for computers and labor go up. So a drop in the price of capital shifts labor demand to the right. Okay, so looking at this chart, okay, we can look at the effect that an increase in the price of capital has on the demand for labor. And it depends on, the relationship of input. So if they're substitutes, if labor and capital are substitutes, then the substitution effect is that labor is then used in place of capital. And then the output effect is that since capital is higher in price, this increases overall production costs, which then decreases output, and then less of capital and labor is used. So in this case, the demand for labor, all right, if the substitution effect is greater than the output effect, then demand for labor shifts to the right, it increases. However, if the output effect is greater than the substitution effect, then demand for labor decreases, it shifts to the left. And if labor and capital are complements, okay, then there is no substitution effect because one does not take the place of the other. They're both used together, so there's no substitution going on. However, there is an output effect, and if capital increases in price, then production costs rise. This would decrease output, so the firm would demand less capital and therefore less labor as well. So demand for labor decreases. Okay, this is a great summary slide. So we have the determinants of resource demand, change in product demand, change in productivity, change in the price of another resource over here. And some examples. So change in product demand. So whenever the demand for the final product increases or decreases, and the demand for their inputs also increase or decrease. So for example, if gambling becomes more popular, then more casinos may open and the demand for workers will increase for casinos. Consumers decrease their demand for leather coats, so the demand for tanners will also decrease. The federal government increases spending on homeland security, so therefore the demand for security personnel will increase. Change in productivity, an increase in the skill levels of physicians increases the demand for their services. So the better trained and educated physicians are, then the higher the demand is for their services. Computer-assisted graphic design increases the productivity of and the demand for graphic artists. Change in the price of another resource. So an increase in the price of electricity increases the cost of producing aluminum. Therefore, output of aluminum drops and their demand for aluminum workers also drops. The price of security equipment used by businesses to protect against illegal entry falls. So the demand for night guards also decreases. Why? Because security equipment is now taking the place of night guards. They're substitutes. The price of cell phone equipment decreases, reducing the cost of cell phone service. And so this increases the demand for cell phone assemblers. So if cell phone equipment becomes cheaper, then more people would buy cell phones. Some economies of scale here would be realized. And therefore, the demand for cell phone assembler increases. Health insurance premiums rise, and firms substitute part-time workers who are not covered by insurance for full-time workers who are. So this has been one of the criticisms of Obamacare, is that now firms have to provide health insurance for full-time workers. And so they tend to be hiring more part-time workers, because since they're not required to pay health insurance for part-time workers, it's cheaper for firms to do so. And so the demand for full-time workers shift to the left, and the demand for part-time workers are shifting to the right. Okay. So the top 3 fastest growing U.S. occupations are personal care aides, home health aides, and also biomedical engineers. The baby boomer population is aging and they are retiring, and so now they are needing more healthcare assistance. And some of the fastest rapidly declining U.S. occupations are shoe machine operators, postal service mail sorters, and postal service clerks, and that is because a lot of automation has replaced these jobs. Now machines are doing the jobs that these postal workers used to do. Okay, so we can see over here, fastest growing occupations, home care aides. And so, from 2010 to 2020, it's estimated to be about a 70.5% increase. Home health aides, biomedical engineers, masonry helpers, carpentry helpers, vet technologists, iron workers, physical therapy assistants, etc. And notice that, in these top 10 occupations, half of them are in healthcare. And then for the most rapidly declining U.S. occupations, again, these are occupations that have largely been replaced with either machines or through increasing our demand for imports. So therefore, we don't need so many workers here to make domestic goods. Okay, and then of course, resource demand is subject to elasticity. What affects elasticity would be first the ease of resource substitutability. So the more substitutes a resource has, the more elastic the demand for that resource will be. If labor can easily be substituted for capital, then the demand for labor would be elastic. Or let's say a widget can be used producing either natural resource A or natural resource B. If natural resource A goes up in price and natural resource B stays the same in price, then since they both suffice to produce the widget, then the demand for natural resource A would be elastic, sensitive to price changes, since the firm can just easily substitute natural resource B. And if the resource doesn't have any close substitutes, then the demand for that resource would be inelastic. Also, the elasticity of product demand. So how elastic is the demand for the output that uses the resource? If the demand for the output is elastic, then the demand for the resource also tends to be elastic, and vice versa. And third, ratio of resource cost to total cost. So in other words, the higher the ratio is, if that certain resource makes up most of the total cost, then the demand for that resource is elastic. So, for example, if labor is the only resource, let's just go to the extreme, and the price of labor increases, then this would increase all the cost curves for the firm and affect production of output negatively. But however, if the cost of labor goes up, but labor cost is only, let's say, 15% of the total cost, then an increase in the cost of labor won't affect total cost greatly, and so the demand for labor would be more inelastic. Okay, and the formula for elasticity of resource demand is a percentage change in the resource quantity divided by the percentage change in resource price. So we're looking at how sensitive resource quantity is in response to a change in the resource price. Okay. So we're going to look at what combination of resources cost the least and what combination of resources will maximize profit. Okay. So if we want to look at which combination of resources will minimize cost, then we need to find where the marginal product of labor divided by the price of labor equals the marginal product of capital divided by the price of capital. However, the least cost rule doesn't necessarily give us the output combination that maximizes profit. There are several different combinations, of labor and capital where they can be equal to each other and the least cost rule is realized, but there's only one level of output that can maximize profit, and so we will study this in the next slide. Okay. When each resource is employed to the point where its marginal revenue product is equal to its price, then the firm has produced the profit maximizing level of output. Okay. So the price of labor should equal the marginal revenue product of labor, and the price of capital should equal the marginal revenue product of capital. Okay, and to write this out a little clearer, marginal revenue product of labor divided by the price of labor equals the marginal revenue product of capital divided by the price of capital. Okay, and so since the marginal revenue product of labor is equal to the price of labor, so for example, if the marginal product of labor is 8 and in its profit maximizing point the price of labor is 8, then the ratio should be 1. Well, let me do this in blue. 1. And then again, at the profit maximizing point, the marginal revenue product of capital should equal the price of capital, which would also make this ratio 1. Okay. All right, so working out an example here, let's start with different least cost combinations. So let's say this firm wants to produce 50 units of output. And so they can find different combinations of labor and capital that would minimize the cost of producing 50 units. Okay, so, this would be through trial and error, but so we were not on this slide forever. Okay, if we were to play around with some of the numbers, we would find one possible combination would be 3 units of labor. Okay, and just for really quick reference, for least cost, okay, it's where marginal product of labor divided by the price of labor equals marginal product of capital equals the price of capital. Okay, so playing around, we would find that the third unit of labor would produce 28 units, and the second unit of capital would produce 22 units. And so that would be total output of 50. And, okay, the marginal product of labor from the third unit of labor is 6. Okay, the price of labor is 8. So we can simplify this to, divided by 2, divided by 2. So we get 3/4. And for the second unit of output, okay, marginal product is 9. And the price of capital is 12. Okay, we can divide this by 3 to simplify to 3/4. Okay, so it satisfies our least cost equation, where 3/4 here equals 3/4 here. Okay. Okay, but that combination does not maximize profit. Let's find the maximizing combination of labor and capital. Okay. And in this case, it would only be one specific combination. Unlike where the least cost combination, there can be various combinations that satisfy the least cost equation or condition. For profit maximizing combination, it has to satisfy marginal revenue product of labor divided by the price of labor equals the marginal revenue product of capital divided by the price of capital. Okay. And so again, through trial and error, and to save time, we'll find here that it's the fifth unit of labor. Okay, it gives us a marginal revenue product of 8. The price of labor is 8. And here we see that the third unit of capital gives us a marginal revenue product of 12. And the price of capital is 12 and equals 1. Okay, and so 5 units of labor and 3 units of capital is a resource combination that will maximize profits. And we also see here that this combination also satisfies the least cost rule. Okay, so the least cost rule, again, marginal product of labor divided by the price of labor equals marginal product of capital divided by the price of capital. Okay, so the marginal product of labor for the fifth unit is 4. The price of labor is 8, so we get 1/2. And the marginal product of capital at unit 3 is 6, and the price of capital is 12. So that also equals 1/2. So they are equal to each other. So the profit maximizing output also satisfies the least cost rule. The marginal productivity theory of income distribution, okay, basically states that our income should be equal to our value. Okay, so if I'm more productive in the same role that you're in, I should be getting paid more than you. This doesn't always happen, and of course there's some criticisms to this. First is inequality. They say that marginal productivity is unequal because some people have just had a better lot in life, grow up in stable families, haven't, did not grow up in poverty, have had their college paid for, and so therefore that makes them more productive, whereas other people in life, grow up in broken homes, grew up in poverty, and getting to college and getting an education has been much harder for them. Also, some people own more resources, such as land, just through inheritance, whereas other people don't inherit anything. So all these resources are also distributed unequally. And then market imperfections as well. We have like labor unions, and they make wages usually above market equilibrium. Also, some people will argue discrimination. I mean, we've seen that for the same role and for the same experience, women often get paid less than men. And some firms just don't pay their workers very well, whereas other firms will pay efficiency wages, above equal or above market wages. Okay, so in case of input substitution, we're going to look at ATMs, but this also happened in the agricultural sector where machines replace a lot of human labor. And in the short term, it's not fun for those workers, but then eventually they can get trained and move on to even higher paying industries. So banks use ATMs now instead of human tellers. I mean, we still have human tellers, but not as many as we used to before. And this helped banks achieve the least cost combination of resources. And these former tellers, they can now find new jobs and go to other industries that are growing. So a lot of times, we focus on the fact that, ATMs might have replaced, workers, but what's happening is other industries are now demanding more labor, and so those workers can go to other industries. It usually doesn't result in a net loss of jobs as well. And also ATMs, satisfy customers. I know I'm very happy that I can just go to an ATM versus having to go to a teller every single time I needed to withdraw cash. All right, and this concludes chapter 14.